Hello everybody, and welcome to this video on the parts of circuits. Before you watch this video, you need to have a copy of the notes so that you can copy the words down that are in blue. Let's get started. So we learned about sources, cells or batteries, and how that can provide electrical charges to form electricity. So chemical energy comes from a source like a cell or battery and causes charges to move through a conductor, like wires, carrying energy to an electrical device, like your cell phone. The moving charges, the moving electrons in that wire, are called electric current. The symbol for current is a capital I, and current is measured in a unit called amperes, or amps for short, and its symbol is a capital A. So we have electrons flowing through wires usually to get to something called a load. A load is a device that converts electrical energy into another form of energy. And as electrons pass through a load, they lose energy because the electrical energy is converted to another type of energy. So for example, a light bulb is a load, and it transforms electrical energy into light energy. I'm going to explain how in a couple minutes. A radio is a load that transforms electrical energy into sound energy. And a load resists the flow of current. So the load resists, another word for resist is like hinders or slows down the flow of current. Electrons in the current collide with atoms that make up the load or with each other, and the collisions interfere with the flow of current. So I'm going to show you what I mean. So the amount that the current is resisted or hindered or slowed down by a load is called resistance. And it describes the amount that the current is slowed down. So the symbol is a capital R. The units are, this is kind of weird, it's a Greek capital letter omega. So you do like a little foot and then most of a circle and then another little foot. And the unit is called ohm, O-H-M. So how does this work in a light bulb? So in a light bulb, the charges come from a large wire, like an electrical cord, into a very thin wire that's called a filament. The filament is the part of the light bulb that lights up. If you look really closely in a light bulb, you can see like a tiny little wire coiled up in there. Since the charges have less room as they go from this thick wire into a thinner filament, they collide with each other and squeeze together, so they slow down. So the filament resists the movement of charges, and it gets really hot in here. The heat makes the filament light up. So a property of the materials that make up a filament is that when they get hot, they light up. Now conductors have to form a closed loop. So conductors are things like wires, metal wires. They have to form a closed loop to allow the current to flow. It won't flow if it's open. And we call this an electrical circuit. A source, a load, and wires in a closed loop make a circuit. Okay, so you need to have, for example, in this one, a source, which is our electrochemical cell. It could also be a battery, it could be a plug from the wall. We have our load, which in this case is a light bulb, and then we have conductors or wires forming this closed circuit so that current can flow through. A short circuit happens when you have a circuit with resistance that's too low. So there's not enough slowing down the current, and that makes the current so high that it's dangerous. So for example, in this circuit, if there wasn't a load, a light bulb, to resist the flow of the current would be so large that the conductor, the wire, would get really, really hot and start a fire. So that's what a short circuit is. So let's go through step by step what current can look like in a circuit. So here's our source. Here is the current. Here's the wire. Okay, and here is the load. So the negative terminal of the source repels the negative charges already in the conductor. So in your wire, you're going to have electrons, and when you plug it into your source, the negative terminal remember similar charges repel. So it's going to push those negative charges away from it. The positive terminal over here is going to attract because opposite charges attract. So it's going to pull those electrons into the positive terminal. And then electrons are going to start moving along this conducting wire. Okay, so negatives are getting pushed from this end and pulled from this end. So they're going to start this flow or current. As the electrons pass through the load, which in this case is a light bulb at B right here, they transfer some of their energy to the load. So electrical energy here is being converted into light energy in our light bulb. And you can see that there's resistance happening because the filament is thinner than the wire. So the electrons then leave the load and return to the electrochemical cell or the source. Electrons enter the electrochemical cell, combine with the positive ions here to become neutral. And over time, we're going to have fewer and fewer electrons at the negative terminal, fewer and fewer positive ions at the positive terminal. But this little guy here, it represents chemical energy, which keeps separating the charges. However, a lot of batteries do have a lifetime, so the chemical energy can only convert for so long before the battery dies. So in a typical circuit, you can use a switch to control the current. So you can see in A up here, the switch is open. So that means the circuit is open, so the current can't flow. There's no pathway for it to follow from the negative terminal over here to the positive one because the switch is open. In the one down here, the switch is closed, so the circuit is closed and the current can flow. So it comes from the negative end, through the bulb, over here through the switch, and then back into the positive terminal. So it can flow, and the light is turned on. Okay, so when you hit a light switch, you are closing a circuit. Instead of having to draw a sketch of a little battery and like a little sketch of a light bulb every time, we can use these symbols and draw something called a circuit diagram. So for example, if you're drawing a cell, you can draw a line with one large vertical line and one small one, and then you're drawing the wire coming out each side. In this diagram, the short end is the negative terminal and the long line is the positive terminal. Okay. Same with down below here, you have a battery. A battery is a bunch of cells connected together, so you can represent this by drawing 3 sets of the short lines and long lines. And again, the short one, the one that ends with the short line, is the positive, and the one that ends with the long line is the one that ends with the big line is positive, short line is negative. Okay, and remember that this electrical potential difference is measured in volts. To show a wire, it's easy, you just draw a line. This is called current, the quantity that flows through the wire, and that's a capital I. I know it looks like an L here, but it's a capital I, and this is measured in amps or amperes. A load can be a lot of different things. It can be a light bulb, it can be a radio, it could be a heater, but we show it by drawing a line that's interrupted by these little squiggles like mountains. A load, remember, introduces resistance, which is a big R, and the unit of measuring resistance is in ohms, which is the little omega symbol. Switches you draw as 2 dots with a little kind of like a doorway in between them. An open switch looks like this. The line does not touch the dot, and closed has a line connecting the 2 dots. So we can use these symbols instead of having to sketch things in our circuit. All right, go ahead and do your practice. I'll see you in class. Let me know if you have any questions. Thanks for watching.